Okay, this question is asking us the chemical properties of an element are determined by what? The possible answers were provided: the number of electrons in the filled shells, the number of electrons in the outer shell, the number of filled shells of the period to which it belongs. Okay, so let's see. Now the period does not tell us about chemical properties. It tells us only how many shells would the atom have. The first period there is only one shell, the second period 2 shells, the third period 3 shells, and so on. That's what the periods tell us. They don't tell us about the chemical properties. Now, like if you go to a big gathering, you see a lot of people you don't know. To identify the people, you are going to identify them with the outer garment they wear, their coat, for example, if it is winter. When you talk about a person with a friend, say that person that was wearing the blue coat. You talk about the outer garment. Same thing with atoms. What's going to matter is going to be electrons in the outer shell. They are the ones that are going to determine the chemical properties. Remember, electrons in the outer shell is what we call the valence electron. The valence electrons. The outer shell, we call it the valence band or the valence shell. Valence electrons are what's going to matter in the chemical properties. They are the ones that are going to be transferred if it was an ionic bond, or shared if we have two non-metals and we have a covalent bond. Now, they are shared in covalent bond, the valence electrons. They are, if we have a metal and a non-metal, we are going to have an ionic bond where the valence electrons are going to be transferred from the metal to the non-metal. It's not the number of the electrons in the filled shells that's going to matter. It's the number of electrons in the valence band. Now, the grouping in the periodic table, the groups, each group is made up of atoms that have the same number of valence electrons, the same number of electrons in the outer shell. That's what determines the groups. Group 1, for example, all atoms in group 1 have 1 electron in the outer shell. They have the similar chemical properties. All elements in group 2, they have 2 electrons in the outer shell. So they have the same chemical properties. All elements in group 13 have 3 electrons in the valence band. They have the same chemical properties, and so on.